A very good day to all of you students. So welcome to the Banovignanik Science Camp Day 2. So your students, in today's lecture, we will be doing the chemistry section of the Banovignanik Science Camp. So once again, a very warm welcome to all of you to the chemistry part of the science camp. Now students, when we say science camp or any camp, for example, the first thing that comes to our mind is a campsite. So as you can see over here, there is this beautiful campsite by a lake. Now you can see some tents, you can see a wooden fire burning, then there is a lake behind with some hills around and greenery everywhere. So students, whatever you see over here in this campsite, we can classify them as living and non-living things. Whereas if I have to give a collective term to the living and non-living things, that term is nothing but matter. So students, what exactly this matter is? Matter, students, is anything that occupies space and has mass. Matter is anything that occupies space and has mass. Now, for example, over here we have a tent. Now, the tent is occupying some space on the ground. At the same time, when we are packing the tent and when we are carrying the tent, that tent has some mass, which means tent is a matter. Even the mobile phones or the tablets or the laptops on which you are watching this presentation, they also occupy certain space and they also have their individual masses. So they also are called as matter. Even we, human beings, we have some mass. At the same time, we occupy some space. Then we human beings are also a part of matter. So students, anything that occupies space and has mass is called as matter. Now we have studied that matter physically exists in three states. Matter has three states. The very first state is the solid state. Now as you can see, the ground on which the tents are pitched, the stones, the wooden logs, and even the tents themselves are all in the solid state. Then the second state of matter is the liquid state. So the lake behind is in the liquid state. Water है ना उसके अंदर, तो obviously it is in the liquid state. And at the same time, over here, this bonfire that you are seeing, there are some gas vapors rising up. So students, the third state of matter is the gaseous state. So all these matter, that is solid, liquid and gaseous state of matter, are made up of some or the other particles. Now students, for example, here we have a night scene of the camp. Now let's say morning में when you wake up, the bonfire has died out and now you have these charcoal or coal pieces burning instead. पूरा का पूरा bonfire die out हो गया है. It's stopped burning and now we have these charcoal or coal pieces which are burning instead. Now students, when scientists started studying the piece of coal and when they saw what is the coal made up of, they concluded that the coal or the piece of coal is made up of tiny, tiny particles. The piece of coal is made up of tiny, tiny particles which are nothing but carbon. So, over here, students, the most simplest part of coal, matlab, when I went on dividing coal further, or when the scientists went on dividing the coal further, at the end they came across these small tiny particles which could not be divided further, which were the simplest form. So, such simplest forms of matter which cannot be divided further is called as an element. So, students, over here in this coal, carbon is the element present. Now, at the same time, we have this air around us. Now, in the air, the most important gas, which is oxygen. This oxygen gas is in the form of O2 molecule. Now, students, As we human beings are social animals, we require friends, we require partners to continue staying our life properly. मतलब दिमाग खराब ना हो जाए वैसे sanely. So same way students, for oxygen to exist in a stable state, it cannot exist as a single atom of oxygen. Instead, it exists in the form of O2 molecule. So two atoms of oxygen come together to form an oxygen molecule. Now students, what was happening when burning was taking place? So the coal in the carbon in the coal, when it got burnt, when we combusted it, when we burnt it, it started reacting with oxygen. Why oxygen, students? We all know oxygen is a supporter of burning. Without oxygen, jalna possible nahi hai. So carbon from coal reacts with oxygen from atmosphere, and when it does so, it combines together to form a new type of compound, which is carbon dioxide, which is carbon dioxide. Now students, carbon in coal was combustible, that is, it was capable of burning, whereas oxygen is a supporter of burning. But now this compound, carbon dioxide, it is neither combustible nor a supporter of burning, and that is why we use carbon dioxide in fire extinguishers. So students, as you can see, the properties of carbon dioxide are completely different than the properties of coal and oxygen respectively. So that is why this group of elements, that is CO2, is called as a compound. So what is a compound, students? So compounds is formed when two or more than two elements combine chemically. That is, they form a bond chemically in a fixed proportion. This is called as a compound. So what do you mean by the term fixed proportion? Carbon dioxide में there always will be one carbon bonded to two oxygen. Yes, someone just gave that example. Water. In water, two hydrogen atoms combine with one atom of oxygen. So over here also, there is a chemical combination taking place. And students, this is fixed throughout. चाहे तुम अमेरिका जाओ, चाहे ऑस्ट्रेलिया जाओ, चाहे यूरोप जाओ, चाहे अफ्रीका जाओ, everywhere the formula for carbon dioxide is CO2. That is, it is fixed. So compounds are found when two or more elements combine chemically in a fixed proportion. Now students, this carbon dioxide gas was rising up. That is, it was mixing with the air around. So we all know that air contains these following gases, that is nitrogen, oxygen, carbon dioxide, water vapor, and other gases. Now students, we call air as a mixture of gases. We call air as a mixture of gases. What is a mixture, students? Mixtures are found when elements and compounds. Mixtures are found when elements and compounds are just mixed together. They are not combining. They are just mixing together in any proportion. So, what do you mean by that any proportion? You may have heard that when we go on a higher altitude, that is when we climb a mountain, the oxygen quantity goes on decreasing. Whereas when we go to the interior regions away from the sea, there the humidity goes on decreasing. That is, the water vapor goes on decreasing. So what you see, two gases which are there in air, oxygen and water vapor, they decrease and increase depending upon the region where you are traveling in. So students, the proportion of these gases in air is not fixed, and they are just present. That is, नाइट्रोजन ऑक्सीजन एक दूसरे के साथ रिएक्ट करेंगे नहीं, कार्बन डाइऑक्साइड वाटर वेपर एक दूसरे के साथ रिएक्ट करेंगे नहीं. So they are just present in the air as individual gases. So what do we understand over here? Mixtures are formed when elements or compounds are mixed together in any proportion. So mixtures are made up of compounds and elements. So over here, students, we have a compound, or we have two compounds, that is carbon dioxide and water vapor. Now let us say if I happen to break the carbon dioxide, in the end, what will I get? I will get carbon and oxygen. Similarly, if I break water vapor, in the end, what will I get? Hydrogen and oxygen. That is, I am ending at the simplest form of matter, which is element. So every matter in the end is made up of some or the other type of element. Now, students, we have another example. Over here, I have a slab of gold. Now, when I keep on breaking the pieces of gold to tiny, tiny particles, at the end, I will get atoms of gold. At the ends, I will get atoms of gold. So basically, every matter is made up of tiny particles called as atoms. So basically, the most fundamental unit of matter is called as an atom. So even elements are made up of atoms. Even elements are made up of atoms. Now, students, atom is a very teeny tiny particle. Atom is a very teeny tiny particle. बहुत छोटा है. So, did atom come and say, "Hi people, I am atom"? Obviously not. Atoms were discovered, and we have studied about it in the chapter Structure of an Atom. So, the first scientist, or I would say, there was this Greek philosopher by the name Democritus. By the name Democritus. So, what did he say? He looked at a drop of an ink. He looked at a drop of an ink and he realized that we could write too many things by just a single drop of ink. That is, if he dipped the feather in water, or the quill in ink, sorry, when he dipped the quill in ink, the tip of the quill had only some drops of ink, but using even those some drops of ink, he could write an entire sentence. So thereby he postulated, that is, he reasoned out that matter is made up of tiny, tiny particles called as atom. He did not give the word atom. Instead, he called these indivisible particles as atomos. He called these indivisible particles as atomos. So in Greek, the word atomos means anything which cannot be divided further. Anything which cannot be divided further. Uncuttable. So matter, the fundamental unit of matter, which cannot be divided further, hence today is called as atom. So this was the Greek thinker, or the Greek philosopher Democritus's theory. There were other scientists as well who contributed to the discovery of an atom. So Democritus was in Greek. At the same time, in India, we had Rishi Kannad. Rishi Kannad also said that matter is made up of tiny particles called as Paramanu. So he saw this by looking at a fist full of rice, or a fist full of grains. He said that as the fist of grains contains tiny particles, which are the food grains, he said that even matter consisted of tiny particles, and he named them as Paramanus. He named them as Paramanus. तो ऋषि कन्नड़ ने वो डिस्कवरी किया इंडिया में, डेमोक्रिटस ने वो डिस्कवरी किया ग्रीस में. And at that time, they did not have WhatsApp, Snapchat, email, or Instagram. So that is why the two discoveries were not known to each other. मतलब डेमोक्रेटिस को नहीं पता था कि ऋषि कन्नड़ ने बोला, ऋषि कन्नड़ को नहीं पता था कि डेमोक्रेटिस ने बोला. So that is why we call them together. We use their names together. Rishi Kannad discovered it in India, whereas Democritus discovered it in Greek. Then the actual theory of an atom was given by John Dalton, which was called as Dalton's atomic theory, where he finally stated that matter is made up of indivisible particles called as an atom. And then, after John Dalton postulated his theory, there were various scientists who studied the structure of atom. We had Thomson, who gave the plum pudding model. Then we had Rutherford, who performed the gold foil scattering experiment. Then we had Niels Bohr, who said that electrons revolved in specific orbits, just like our solar system, where planets revolve around the sun. And then we had James Chadwick, who contributed towards the discovery of the neutrons present in the nucleus. So all these various scientists and philosophers, they gave us the structure of an atom. So as we all know, atom over here is made up of three subatomic particles. Atom is made up of three subatomic particles, namely protons, electrons, and neutrons. Protons, electrons, and neutrons. Now, students, protons are positively charged. P for proton, P for positive. So, protons are positively charged, whereas neutrons are neutral. That is, they do not have any charge. Protons are positive, neutrons are neutral, and electrons, which are revolving in the orbits, as you can see over here, they are negatively charged. So protons positive, electrons negative, neutrons neutral. That is, they don't have any charge. So now students, let us study the electron, proton and neutron का basic properties या characteristics जिसको बोलते हैं. So first we'll study the charge. So as we just discussed, electrons are negatively charged, protons are positively charged, and neutrons have no charge. Then electron, proton and neutron. Now when we are drawing the structure of an atom, तो वहां तो हम लोग नहीं लिखेंगे electron, proton, neutron. What will we do? We will use some symbols. We'll use some symbols. So electrons, students, is represented by small letter E with a minus sign. Electron is represented by small letter E with a minus sign. Protons is represented by a small letter P with a plus sign, whereas neutrons is represented by only N or N raised to 0, that is no charge. Now talking about the location, that is where are these subatomic particles present inside the atom. So electrons, as we just studied, or as Niels Bohr told us, electrons revolve around the nucleus in their respective orbits or in their discrete orbits, whereas protons and neutrons are present inside the nucleus, whereas protons and neutrons are present inside the nucleus. And that is why we call protons and neutrons collectively as nucleons, collectively as nucleons. So what is a nucleon? Nucleon is basically proton and neutron present inside the nucleus. So electrons are in the orbits, whereas protons and neutrons are in the nucleus, hence they are called as nucleons. Now talking about their masses. Yes, students, protons, electrons and neutrons, even though they are small, they have some mass. Why? Because after all, they are matter. And we just studied some time back that matter has mass. So electrons have a very negligible mass, whereas protons and neutrons are approximately 1 unit of mass. That U is nothing but Dalton. That U is nothing but Dalton. So protons and neutrons weigh approximately 1 Dalton, whereas electrons have negligible mass as compared to protons and neutrons. So now students, as we are discussing about electrons, electrons are the main particles present in an atom because they are the particles that take that take part in a reaction. So we will be studying the arrangement of electrons. So that is called as electronic configuration. arrangement of electrons in each orbit or shells. So orbits are also called as shells. So electronic arrangement is called as electronic configuration. Now students, the electrons, they are not just randomly arranged, but they follow a rule called as maximum capacity of a shell, called as maximum capacity of a shell, given by the formula 2n square, given by the formula 2n square. So n over there, students, is the orbit number, is the orbit number. So what do you mean by orbit number? We all have studied that atom has k shell, l shell, m shell, n shell. So k के जगह पे if I substitute number 1, k is the first shell. So when I substitute, n is equals to 1. So पहले square करो, फिर multiply करो. So 1 squares are 1 multiplied by 2. So the maximum capacity of the k shell is 2, which means in the first shell, 2 electrons can be maximum. We cannot put more than 2 electrons in the first shell. 2 से कम हो सकता है, लेकिन 2 से ज्यादा नहीं हो सकता. Okay, so that is the meaning of maximum capacity. So the K shell can only take 2 electrons, not more than that. Now let's go to the L shell, that is number 2. So again, पहले square करो, फिर multiply करो. So 2 squares are 4, 4 twos are 8. So the maximum capacity of the second shell is 8. So second shell में 8 electrons can go. 8 से ज्यादा नहीं, 8 से कम हो सकता है. So now let us quickly calculate for the third shell. So झट्टापट्टी substitute n is equals to 3. पहले square करो, फिर multiply करो. So 3 squares are 9, 9 twos are 18. So very good students. Third shell में there will be 18 electrons. And fourth shell similarly, 4 squares are 16, 16 twos are 32. So fourth shell will have 32 electrons maximum. 32 से ज्यादा नहीं, 32 से कम हो सकता है. So that is the maximum capacity of the first 4 shells. Now students, remember one thing. If any other shell other than the K shell, if any other shell other than the K shell is the last shell, for an atom to be stable, that last shell should have 8 electrons. That last shell should have 8 electrons. Only then will it be called as a stable atom. Capacity कितनी भी होने दो, अगर n shell, the fourth shell is the last shell. If n shell, fourth shell is the last shell, if that is the last shell for a particular atom, then for that atom to be stable, the fourth shell should have 8 electrons. If not, then it is not stable. So you will ask is to sir, except K shell likha hai, what will be the stability for K shell to be the last shell? So remember students, whenever the K shell is the last shell, whenever K shell is the last shell, then it should have 2 electrons only. It should have 2 electrons only, not less than that. And if any other shell, that is L shell is the last shell, M shell is the last shell, or N shell is the last shell. If any other shell is the last shell other than the K shell, it should have 8 electrons only. Only then will it be called as a stable atom. So students, let us now understand the stability in a better way. So for an atom, for atoms who don't have 8 electrons in the last shell or 2 electrons, then what should they do or what should they achieve? So for an atom to become stable, they should either have a duplet state or an octet state. They should either have a duplet state or an octet state. So what do you mean by a duplet state? So when the K shell is the last shell, when K shell is the last shell, it should have 2 electrons only, not less than that. Whereas octet state means whenever any other shell is the last shell other than the K shell, it should have 8 electrons. So students, for atoms to achieve stability, they usually exchange or share electrons. They usually exchange or share electrons in order to become duplet or octet. So let us study that by checking the electronic configuration of first 18 elements. So students, the first element is hydrogen. The atomic number of hydrogen is 1, which means it has 1 electron. So that 1 electron will go in the first shell as shown over here. Helium. The atomic number of helium is 2. That means it has 2 electrons, which will go in the first shell itself. Now students, over here for helium, the first shell is the last shell and it has 2 electrons, which means helium is stable. That is, it has achieved its duplet state, whereas hydrogen is not stable. Uska duplet state is incomplete. Understanding, students? Let's check the next element, that is lithium. The atomic number of lithium is 3 and the electronic configuration is 2, 1. That is 2 electrons in the first shell and 1 electron in the second shell. So students, over here, lithium ka last shell is the second shell. So what will lithium do? Is it easy for lithium to take 7 electrons and complete its octet? Or will it be easy for lithium to give 1 electron and complete duplet? So when we speak logically देखा जाए तो it is easy for lithium na to give 1 electron and complete duplet. So that is what lithium will do. Lithium will lose that 1 electron from its outermost orbit and thereby complete its duplet state and become stable. Let's check about the next element, that is beryllium. The atomic number of beryllium is 4. Electronic configuration 2, 2. So again for beryllium, the second shell is the last shell, which has 2 electrons. So what will beryllium do? Easy peasy lemon squeezy. Beryllium would rather give 2 electrons than take 6 electrons. So beryllium gives 2 electrons and becomes duplet. Let's go to the next element, that is boron. Atomic number 5, electronic configuration 2, 3. So over here also students, boron would give 3 electrons than taking 5 electrons in order to become duplet. Carbon, atomic number 6, electronic configuration 2, 4. So now students, carbon दुविधा में पड़ गया. Carbon can either give 4 electrons and complete duplet, or carbon can take 4 electrons and complete octet. But carbon does neither. It neither gives electrons nor takes electrons, but it shares. So carbon shares 4 electrons to complete octet. Carbon shares 4 electrons to complete octet. So carbon will neither give nor will it take. Instead, it will share. Then nitrogen, atomic number 7, electronic configuration 2, 5. So over here students, 5 electrons in the second shell. What would be easier? Give 5 or take 3? Logically, obviously, it is easy for nitrogen to take 3 electrons. So nitrogen will take 3 electrons and complete octet. Oxygen atom is the next one. Atomic number 8, electronic configuration 2, 6. Again over here students, oxygen would rather take 2 electrons and complete octet than give 6 electrons and complete duplet. Okay, so moving on to the next element, that is fluorine. Moving on to the next element, that is fluorine, electronic configuration 2, 7. Now you all tell me students, what would fluorine do? It has 7 electrons in the second shell, which is the last shell. Absolutely correct. Fluorine will take 1 electron and complete octet rather than giving 7 electrons to complete duplet. Brilliant students, brilliant. Neon, atomic number 10, electronic configuration 2, 8. So will neon give, take or share? Obviously not. Neon ka second shell is the last shell and it has completed its octet state. That is, neon is stable. So in the similar way, the other elements like sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. In the similar way, students, if you check, all these elements are also having the same type of electrons in the third shell, which for them is the last shell now. So it's similar to what we just saw before. So sodium, magnesium, aluminium will give electrons, silicon will share electrons, phosphorus, sulfur, and chlorine will take electrons, whereas argon is electrically stable, that its octet is complete. So students, what we were just saying, that some elements give electron, some elements share electron, some elements take electron in order for them to become stable. So the number of electrons which are given, taken or shared has a term. So we will study that term shortly. But now students over here, we have a fun way of remembering the first 20 elements. So what we just saw, the first 18 elements, अगर उसमें हम लोग 2 एलिमेंट और ऐड कर दें तो वो हमारे फर्स्ट 20 एलिमेंट्स हो जाएंगे एंड हर एक का नाम याद रखना बहुत डिफिकल्ट हो जाता है. So here I have a shortcut for you all to memorize the first 20 elements. The shortcut goes as hi, hello, listen to BBC News on Friday night. So if you see over here, these are the first 10 elements. H of hi is hydrogen, He of hello is helium, Li of listen is lithium, and so on and so forth. So see how fun it is to study chemistry using these nice mnemonics or shortcuts. Then I have another shortcut to remember the next 10 elements. So that shortcut goes as na mango alia se Pepsi, soda, cola और काजू केक्स. सो यू विल से कि सर आलिया भट्ट से कौन ये सब मांगेगा, बट इतना टेक्निकलिटी में क्यों जाना. योर दिस इज अ शॉर्टकट. सो ना स्टैंड्स फॉर सोडियम, मांगो का Mg स्टैंड्स फॉर मैग्नीशियम, आलिया का Al stands for aluminium, and so on and so forth. So this is a fun way of remembering the first 20 elements. So now coming back to what we were discussing before. So as we said, atoms give electrons, share electrons, or take electrons in order for them to become stable. So the number of electrons that are given, share, or taken, the number of electrons that an atom gives, shares, or takes in order to it become stable, in order for it to become stable, is called as valency of that element or valency of that atom. So students, sodium 2 comma 8 comma 1, what will sodium do? It will give 1 electron. So that is the valency of sodium. So students, Valency is nothing but GST of electrons. GST मतलब हमारे PM मोदी वाला GST नहीं. GST means give, share and take of electrons. So let us understand this थोड़ा detail में. So valency, as I was saying, of sodium, electronic configuration 2, 8, 1. So it has one electron in its outermost orbit. So sodium would rather give one electron and complete its octet state. And that is why sodium gives one electron and its valency is 1, giving of electrons. So the number of electrons that were given is the valency of sodium. Now let's talk about carbon. So carbon, atomic number 6, electronic configuration 2, 4. So carbon has 4 electrons in its outermost orbit and it requires 4 electrons to complete octet. So students, your carbon, as we all know, will share 4 electrons and that is why the valency of carbon is 4 and that is why the valency of carbon is 4. Now you all use your logic and tell me for chlorine atomic number 17 electronic configuration 2, 8, 7. So what would chlorine do? 7 electrons in its outermost orbit. Exactly, absolutely correct. Chlorine will take 1 electron in order to complete octet and therefore the valency of chlorine is 1 and therefore the valency of chlorine is 1. So students, whenever an atom gives electrons, whenever an atom gives electrons, that is, it is giving its negative energy. It is giving its negative energy away. So whenever we meditate, whenever we listen to music, we lose negative energy from our body, which means we become more positive, which means we become more positive. So same logic यहाँ पर लगाओ students. Whenever an atom gives electrons, it becomes positive. It becomes positive. Whereas अगर कोई तुम्हारे कान भरता है, अगर कोई तुम्हारे कान भरता है किसी और के खिलाफ, basically that person is putting some negative energy inside you and you all become angry, you all become furious, एकदम गुस्सा आ जाता है. So basically you all become more negative. So same logic apply over here. Whenever an atom takes electrons, what are electrons? Negatively charged particles. So whenever an atom takes electrons, they become negatively charged particles. They become negatively charged particles. So students, giving of electrons gives positive charge, taking of electrons gives negative charge. So these charged particle students are called as ions, are called as ions, ions, I-O-N-S, ions. So ions are charged particles. Ions are charged particles formed because of giving and taking of electrons. So the positively charged particles are called as cations. Positively charged particles are called as cations, whereas negatively charged particles are called as anions. Negatively charged particles are called as anions. Positively charged cations, negatively charged anions. Cations का pet name or there is another name given to cations, that is basic radicals. That is basic radical. Whereas anions are also called as acidic radicals. Whereas anions are also called as acidic radicals. So students, I have a trick for you all to remember the charges. So anion को students, I am just writing as A-N-I-O-N-S. A-N-I-O-N-S. So what is this? So A वापस से A, N is negative and ions I'm writing as it is. So a negative ions. Now when I take the first alphabet each of O and negative, and combine it with ions, what will I get? Anions. So a negative ion is anion, which means cations are positively charged. So cations are also called as basic radicals and anions are also called as acidic radicals. Now students, as they are opposite in charges, as they are opposite in charges, they will attract each other. They will attract each other, and that is why they form an ionic bond. That is why they form an ionic bond. A bond between two oppositely charged ions is called as an ionic bond. And the compound now made because of this ionic bond is called as an ionic compound. This ionic compound has two names, या two parts in its name. जैसे हमारे में फर्स्ट नेम सरनेम होता है, तो वैसे ही आयोनिक कंपाउंड का टू नेम पार्ट्स होता है. The first part or the first name is always the cation, that is the positive ion, and the second part or the second name, that is the surname, will always be the anion. So for example, sodium 2 comma 8 comma 1, sodium gave one electron and became cation, whereas chlorine 2 comma 8 comma 7 took that one electron and became an anion. So sodium cation, chlorine anion, positive negative attract. तो क्या बनेगा? सोडियम क्लोराइड. बोले तो नमक शमक. So sodium chloride, sodium positive, chloride negative. So first name is always cation and second name is always anion. So that is how we write an ionic compound. That is how we write an ionic compound. Now students, in order for us to make the ionic compounds, we need to remember the valency of every element or the valency of radicals. So this is a valency chart. Now you will say कि sir, ये तो कुछ ज़्यादा ही हो गया. कैसे याद रखने का है इसको? So this, don't worry students, we study it in a more fun way. जैसे हम लोग ने first 20 elements कैसे याद रखे? Using some shortcuts. In the same way, we study valency in a way of a song. So yes students, what you see in front of you, we sing it in a form of a song, which makes us easy to remember the valency chart. So want to hear it? So tighten your seatbelts, tighten your earphones, and let's start singing the valency आरती. But before that, disclaimer, मैं सोनू निगम नहीं हूँ, so I cannot sing in the same way as the singers do, but I will surely try. So let's start. One, two, three, and here it is. OH hydroxide, Cl chloride, Br bromide. I iodide no 3 nitrate, I iodide no 3 nitrate, HCO3 bicarbonate. बोलो HCO3 bicarbonate. AlO2 aluminate, Ag silver Na sodium. बोलो Ag silver Na sodium. H हाइड्रोजन के पोटेशियम, H हाइड्रोजन के पोटेशियम, सबकी वैलेंसी है 1, इन सब की वैलेंसी है 1. Cd कैडमियम, Ca कैल्शियम, Mg मैग्नीशियम. बोलो Mg मैग्नीशियम. Hg mercury zinc Zn, Hg mercury zinc Zn, Ba है बेरियम. बोलो Ba है बेरियम. O oxide S sulfide, CrO4 chromate. बोलो CrO4 chromate. CO3 carbonate sulfur sulfate, CO3 carbonate sulfur sulfate, zincate ZnO2. इन सब की वैलेंसी है 2. Copper Cu iron Fe, both of them have variable valency. हो बोलो both of them have variable valency. copper 1 2 iron 2 3, copper 1 2 iron 2 3, but aluminium Al की valency है fixed 3. So see students, how we study the valency chart in a fun way. Like we sing it along, but at the same time, we study it as well. So students, this is the valency chart. But ये तो हो गया valency chart की बात. अब क्या करें? How to use it? So let us understand how to make chemical formulae using this valency chart. So your students, there are 4 steps in writing the chemical formula. So the first step, students, is to write the name Mrs. Symbols. So if the name is sodium sulfate, if the name is sodium sulfate, so first write the symbols. So sodium का symbol Na, sulfate का symbol SO4. Sodium का symbol Na, sulfate का symbol SO4. Step number 2. Write the valency below the respective formulae. So sodium की valency है 1, whereas SO4 sulfate की valency है 2, which we can get from the valency chart previously discussed. So that we write it below the formula. And now students, next step we cross multiply. Next step we cross multiply. That is how we do in maths. Criss cross. So 2 goes to sodium and 1 goes to sulfate. And thereby the final formula becomes Na2SO4. The final formula becomes Na2SO4. That is sodium sulfate. So this is how we make the chemical formulae of ionic compounds. So let us study a few compounds more. So first is potassium hydroxide. Potassium hydroxide. So first we write the symbol. The symbol for potassium is K and that of hydroxide is OH. The symbol for potassium is K and that of hydroxide is OH. Then what do? We write their valencies below the symbols. So potassium and hydroxide both have valency 1. Both have valency 1 and then we crisscross it. So when we crisscross K1 OH the whole bracket 1. Now students, 1 is always understood. That number 1 is always understood and that is why we write the final formula as KOH. So potassium hydroxide ka final formula is KOH. Then let's go to the next formula. So the next formula is magnesium chloride. The next formula is magnesium chloride. So first write the symbol. Symbol for magnesium is Mg and that of chloride is Cl. So Mg and Cl. Next step is to write their valencies. Magnesium ka valency is 2 and chloride ka valency is 1. So after that we crisscross it. So Mg1 Cl2. So we always know that 1 is understood. So MgCl2. That is the formula for magnesium chloride. That is the formula for magnesium chloride. Okay. So understood how to use the valency chart. So let us do the next formula of silver nitrate. So symbol of silver, that is Ag, and that of nitrate is NO3. No 3. So AgNO3. Then we do the valency. Silver ka valency is 1 and NO3 ka valency is also 1. So when we cross multiply, the formula becomes AgNO3 the whole bracket 1. So 1 is always understood. That is why the formula of silver nitrate is AgNO3 or अग्नोत्री. जैसे अग्निहोत्री किसी का सरनेम होता है तो वैसे ही अग्नोत्री AgNO3 is the formula of silver nitrate. So I will give you all some time to do the formula for aluminium oxide. So the first step students, aluminium का symbol is Al and oxide का symbol is O. So go back to the valency chart and try doing the formula. So yes, correct. The valency of aluminium, first writing the valency of aluminium, that is 3. Aluminium की valency है fixed 3 and oxide का valency is 2. So Al के नीचे लिखेंगे 3 and oxide के नीचे लिखेंगे 2. Then we crisscross. So Al के पास 2 आ जाएगा, oxygen के पास 3 आ जाएगा. So the final formula becomes Al2O3. Al2O3. So that is the formula for aluminium oxide. So students, what we gained or what knowledge did we gain from today's lecture? We saw that matter is made up of elements, compounds and mixtures. And all these things have a fundamental unit called as an atom. Every atom is made up of electrons, protons and neutrons. Now, protons and neutrons are collectively called as nucleons because they are present inside the nucleus, whereas electrons revolve in their orbits. Arrangement of electrons in their orbit is called as electronic configuration. Depending upon a certain formula, that is 2n square, called as the maximum capacity, we decide how many electrons can go in a particular shell. Then we studied how atoms attain stability by completing duplet or octet state. That is 2 electrons in the first shell if that is the last shell, or 8 electrons in any other shell if they are the last shell. So for that, atoms usually give, share or take electrons. That is nothing but their valency. And using this valency, we studied how to make ionic formulae. So students, that's it for the chemistry part of the Manovignanik science camp. So thank you for listening so carefully and being such brilliant students. So see you next time. So that's it on my part. Till then, keep smiling, take care, bye bye, and stay safe. Have a great year ahead, students. Thank you so much.